Welcome everyone to this, the fourth event in the Wen Family Chair in Conservation Public Lecture Series. My name is Jessica Meeuwig, and I have the privilege of being your compere, Mistress of Ceremonies this evening. I'm also the director of UWA's Marine Futures Lab and a member of the Oceans Institute. But first, Kaya, the University of Western Australia acknowledges that its campuses are situated on Noongar land and that the Noongar people remain the spiritual and cultural custodians of their land and continue to practice their values, languages, beliefs, and knowledge. Relevant to this lecture, that also applies to their sea country. So welcome to our guests who've come out this winter evening and to Professor Ben Halpern and his family here from sunny California. They've assured me that as California struggles with drought, they also welcome rain. This lecture series is delivered through the Wen Family Chair in Conservation, established in February 2023, and of which I am also the inaugural chair, to my great delight. I'd thus first like to acknowledge May and Chu-Chi Wen for their generosity, but most importantly for their vision of endowing a chair in conservation at UWA, and also making this lecture possible. I'd like to highlight that the first time I met the Wens, they said to me, "So, what's the impact?" And I said, writing lots of interesting papers? No, I did not say that. But what they've always been focused on is it's not just the research. You have to have good research to underpin your impact, but it's all about the impact. And so most of the meetings we have, there's always the question of, so how's this work in your lab relevant? How's it going to have impact? So I always come prepared now. They've trained me well. This public lecture is actually part of the impact as we seek to broaden our collective understanding of the challenges faced by our oceans, but also the solutions that we have available. So supporting this lecture, I'd also like to acknowledge the Jock Clough Marine Foundation, Forrest Hall, and UWA's Oceans Institute. Thank you for your ongoing support in this series because we couldn't do as many as we do without that. I'd also like to personally thank the UWA team that helps put this shindig together, Melissa Hasluck and Antoinette Tan from the Development and Alumni Relations, and from the Oceans Institute, Emily Glover and Vivian White. This year, I'd also like to acknowledge the Selby Scientific Foundation based in Melbourne and the Australian Academy of Science for their excellent decision to award the 2025 Selby Fellowship to Professor Halpern, and thus enabling his travel to UWA. They made an excellent decision. My last job in this introduction is to introduce UWA's Vice Chancellor, who doesn't actually need much introduction, but I also welcome and acknowledge him to this lecture. Given his very full schedule, Professor Chakma's presence reflects his commitment to the work made possible through the endowment of chairs. Over to you, Vice Chancellor.
Kaya Wangju, good evening. I'd also like to acknowledge that we are meeting this evening on the lands of the Whadjuk Noongar, Whadjuk people of the Noongar Nation, and I pay my respects to elders past and present. We are privileged that our university sits on this beautiful land, Whadjuk Noongar Buja, alongside the beautiful river, the Derbil Oregon. And the location actually makes this place a wonderful place to learn and study and to do research. Well, a little bit of background for certainly our visitor, distinguished visitor, a warm welcome. This place has been a place where Aboriginal people gathered and shared knowledge for tens of thousands of years. So we are really standing on a very privileged location. So those experiences were shared through storytelling, other traditional means. In many ways, what we do today through our publication, through our lectures, is also, sharing our knowledge through storytelling. So we are going to wait and listen to our distinguished speaker's story on oceans. I would also like to welcome you all, and particularly Chi-Chi and May Wen, and delighted to see my friend Jock Clough. I didn't expect you to show up, Jock, but I should have, because this is oceans. That's your passion too. Your foresight, the Wens, your foresight, allowed us to establish the chair, and the results are unfolding before our eyes. Lecture being the one example, but there are many other things that are happening. Well, the focus of the inaugural chair, our beloved Professor Jessica Meeuwig, is marine conservation, which of course fits in very nicely with our location, given we are on the Indian Ocean side of the country. And of course, our work crosses boundaries. The Indian Ocean is big. It's not just our country. It goes beyond that. And of course, we do a lot of work in oceans, and we have a lot of entities, but most notable one, because in my mind, that's the glue that kind of brings many of our ocean activities together, is the UWA Oceans Institute. And this chair works very closely with that institute. Well, we all know that oceans are big, cover 70% of Earth's surface, and they are vital for sustaining life. We also know that there are many, many challenges. We are polluting our oceans, and we need to do something about it. The other challenge, of course, as I'm told by the experts, including Jessica, we actually don't know much about oceans, particularly marine life. There is just a lot to learn. And at this university, we are privileged that our colleagues like Jessica bring new knowledge literally every day. We learn about exciting things on all fronts. So that makes the intellectual enterprise of this university a vibrant one, and of course very impactful, looking at it from knowledge generation point of view, enhancing our understanding. The impacts are right there. I think the impact that you are looking at probably more near-term public policy impact. In our mind, those of us who are academic, almost everything we do actually has impact. The question is the time frame it takes for the knowledge that we generate to have some impact. Well, let me take this opportunity to congratulate Jessica on her recent notes or commentary paper in Nature. So those of you who are academic, you know that getting something published in Nature is a big deal. And I think it got published last week. So you know that, Jessica, I follow what you do. Or at least I have people who tell me. And we are very pleased that your work will get that much attention from a reputable journal like that. Let me turn to the chair itself. Well, we are blessed by having the Wens, like many others, like the Cloughs, as friends of the university. And this university actually was founded by generous support from the community. And in our journey, in the progress that I made over the last century plus, we have retained that support from many, many community leaders. We are who we are because of that support. And the Wens continue that tradition. They have been longtime friends of the university and have supported us through their generous philanthropy. Last week, we are pleased to honor their contribution by etching their names on our much beloved and celebrated benefactors wall. So those of you who are not familiar with what that is, it's a wonderful wall where we recognize our benefactors, from the time that we are founded. It's located across the Winthrop Hall. It's on the opposite side of it. So if you're curious, like I am, take a look at the names. You'll see history of WA before your eyes. People who have built Western Australia in modern times. Their names are all there. So I was taking joy in knowing that our current benefactors joined the illustrious list of people, including our founder, Sir Winthrop Hackett. So on my way back here, I was able to take a picture of the wall, and I was able to show May their names because they are not able to attend last week's event. So May and Chichi, thank you very much for your support for the chair, and we are ever so grateful for that. Well, philanthropy has been a key funding source for UWA when we were founded about, century ago. Winthrop Hackett, of course, is the first major benefactor. And a historic note, he was such a wise individual Obviously, I didn't have the privilege of seeing him. Maybe some of you did. I wish I had that privilege. He was wise in many ways, established the university against all odds, because there are people actually who didn't believe that this state needed a university. Just imagine that today. But he won. So not only that, in those days, the notion of establishing endowment was new or non-existent. So he gave us our first endowment. Even more relevant to the chair today, Sir Hackett established our first endowed chair, the Hackett Chair in Agriculture. And that chair had been contributing to the agriculture sector for the last century plus. So tonight's talk and the chair that it brings us together is just a part of that continuum. So over the last 4 or 5 years, we have created a number of other new chairs. So what Sir Winthrop started, we kind of stopped doing it for a while. So we are catching up. So we are feverishly trying to raise chairs. And I'm delighted to have Jock Clough with us. When I brought up the idea of creating more chairs through matching funds, so the first victim was Jock. So I don't think he was totally persuaded, but he loves the university so much, and he wanted to support me as new vice chancellor. He said, "What the heck, we'll start one." I may be a little bit unfair, but he didn't say that, but just his body language, but doesn't matter. He gave us the money, we got the chairs. Thank you, Jock. And today we have 12, so that was 4 years ago. We're having lunch at the University Club. So you got, certainly during my time, the first chair, and I knew that is going to work. Today we have secured 12 chairs, 5 more in the pipeline. So by the time we are done, close the calendar year, hopefully we'll have 70 chairs. What do? Well, they attract top scholars. They allow us to retain top scholars like Jessica. And then they provide resources to the extent that we are able to bring to the table to allow the chairs to do leading edge research. And you'll get some examples of that. So they're very, very important for today and for our future. So together with our community, with our generous supporters, we are building a university that is not only world-class in research and teaching, but also deeply committed in making a difference in the areas that we touch. We don't do everything, but we do a lot of things, be it in health, be it in environment, be it in public policy, a host of other things. And I'm glad that so many of you have decided to join us to hear the lecture. I'm particularly pleased to see, just by looking at the age profile, I'm making assumptions here, some of our HDR and other students, because it's very important for students to be exposed to the scholars, who are at the leading edge of the topics that we are going to hear from. Thank you very much. Jessica, I give back the podium to you. Congratulations again on your Nature's paper.
Thank you. So thank you, Vice Chancellor, including for making me blush a little bit. It is now my pleasure to introduce Professor Ben Halpern, who will present this evening's lecture on the promise and the peril of the blue economy. I've followed Ben's work since his seminal paper on marine parks, published in 2002, as part of his PhD, I believe. And this paper absolutely transformed our scientific discussions about marine parks. They went from a question of, do they work? The answer is yes. To how do we make them most effective? And it was a complete change of the culture around marine parks. Ben indeed was one of the early leaders in the use of big data before we even had that term, and thinking about how do we synthesize multiple studies to get a broader understanding of how the world works. And the synthesis bug bit him hard and has stuck with him, because now he finds himself, since 2016, the director of the National Center for Ecological Analysis and Synthesis, NCES, and I will not say that whole name again. Basically, and it's based at the University of California, Santa Barbara. So NCES, as it's now known in order to avoid that mouthful of name, is the oldest ecological think tank in the world. It's about to celebrate its 30th birthday this year. The outputs from the NCES hosted workshops, working groups are published in the best journals, and have the highest impacts, major impacts on public policy. Now, because I like to count fish, I'm going to go a little bit quantitative. NCEAS has published over 3,500 papers in 30 years, with the top 10 papers cited 120,000 times. That's 1,200 per paper, and tell you what, I'd be overjoyed if I got 1,000 citations on a paper. Maybe for the nature one, I don't know. But NCEAS, more importantly, has also supported 200 postdoctoral fellows and hosted over 11,000 researchers from 70 countries. It's thus a great pleasure to hear from someone today with both a deep and broad knowledge of research and what it takes to drive impact. Just a little bit for myself, just back from the United Nations Ocean Conference in Nice, France. This is held once every 5 years, and it's where national governments come together to make international commitments in support of a resilient ocean. I was delighted to attend an event from the Ocean Decade Australia and hear our newly minted Federal Minister for the Environment, Murray Watt from Queensland, commit to fully protecting 30% of Australia's ocean territory. That means 30% of our ocean territory will have no fishing, no seabed mining. It's what we need to do to get highly protected places and strengthen our Australia's ocean policy. And I can also say from the conference that of direct relevance to this evening, the blue economy was a very, very hot topic. So with that, I look forward to Ben's timely lecture on the blue economy. Please welcome Ben.
Thank you, Jessica, so much for that kind introduction, and to the Wens for hosting this lecture. I'm trying to find where you are, but anyway, thank you so much. It's really a great pleasure to be here. It's my first time in Western Australia, so it's a joy to get a chance to experience Perth and the state. We're going to travel after this to see a little bit more of the country here. So I'm excited to share with you a little bit of my research and my perspective on what I see as both the promise and the peril of the blue economy and what it might mean for the future of humanity really on our planet. And this is one of my favorite views of our planet. It's one of these perspectives that shows how much of our planet is actually the ocean. And to many, they see opportunity, where there is resources to extract or profit to be made, and others, they see an opportunity or a need to protect and set aside this precious resource that so far has withstood a lot of the pressures we put on it. There are a lot of resources in the ocean, a lot of interest in expanding into the ocean to take advantage of that. And this drive to move into the ocean, even more than we have done to date, is really creating both opportunities and risks for what that might look like. So today, this evening, I want to share my own personal journey, both a scientific one and a philosophical one, about how I feel about the blue economy and the rush into the oceans to address our economic and social and sustainability needs. So my story starts about 20 years ago when, along with many others, we began to pull together a lot of disparate information to understand how human activities were impacting the ocean. This is a big synthesis, big data effort to map the cumulative effect of all of these different pressures that we put on the ocean, from climate change to fishing to oil and gas development to coastal development and so on. And in order to do this, we needed to layer on to these maps of the world the different fishing types that were happening, whether they be trawling or pelagic fishing, the global shipping that happens across the planet, and then pulling those together to get this big picture of what became described as the cumulative human impact of our activities on the ocean. This work came out about almost 20 years ago, as I said, and it really changed my own view of what the ocean looks like. It's easy to look out across the ocean and think we're not having much impact on it because it is so truly vast and we don't live in the ocean. And so our footprint might seem less there. But what we found through this work is that 41% of that ocean is heavily impacted already. So this is areas that have already experienced substantial cumulative human impact across these many activities. It's a lot. It's all those orange and red areas that you see on the map there. In contrast, the areas that were lightly touched, these blue areas, represented less than 4% of the ocean. And we found actually that no spot was untouched by human activities. There's nothing that you could call truly pristine left in the ocean. There's just these lightly touched areas. So these were really sobering results, and they set the context for the work I've been doing in the last 20 years and the way I've been thinking about where we're headed with the blue economy moving forward. And so I want to spend the rest of this talk talking about what that might look like and focusing on three stories, three ways that people are looking at the oceans to really solve or address our sustainability issues while also turning a profit, making money off of doing so. And so we're really seeing what I think of as a gold rush, a blue gold rush into the ocean. And I'm going to talk about these three main resources that people are looking at: food, energy, and minerals. And they have different stories behind them, and I want to share some of the science and the perspective of what is behind each of these. So we're going to start with food. And food, as you know, comes from fish and a variety of seafood. And it's driven both by wild-caught fisheries, the historic way that a lot of people have gathered fish from the ocean, but also aquaculture. So this plot shows over the last 70 or 80 years the growth of harvest of seafood from the world's oceans, initially primarily from wild-caught fisheries, those blue colors that you see growing from 1950 onwards. And then starting in about the 70s and 80s, you see the pink colors, which are aquaculture, farming seafood in the oceans. And you can see by 2022, we've gotten to a point where effectively, or essentially, half of all food that we get from the sea is coming from farmed sources. So it's really changed the way that we are using the ocean to produce food for human consumption. When I started my career 30 plus years ago, my perspective on aquaculture was a pretty negative one. It was born out of those early days of aquaculture in the 70s and 80s, when it was not done in a very sustainable way at all. So we see on the top these shrimp ponds that destroy mangrove habitat to grow shrimp, and over the last 30 or 40 years, shrimp farms have destroyed about 30 to 40% of all mangroves globally. And I also saw images of these, salmon farms that were in the fjords of Norway that were creating heavily polluted areas that were killing all sea life in that area. So these were the stories and the pictures and even the science that was coming out of aquaculture at that time that really influenced the way I think about, or thought about rather, aquaculture. I also grew up in the Pacific Northwest of the United States, in Oregon. If you're familiar with that part of the world, salmon is profoundly connected to the culture and the community of all people, certainly the First Nation and indigenous people that have been there for thousands of years, but even the modern communities that really live off of the salmon. And so the idea that you would risk these amazing wild species by farming salmon in the area was something that was just absolutely an anathema to people where I grew up and my family for sure. So this was the context that I was born into in thinking about aquaculture. But about 10 years ago, I got invited to help lead a project to explore aquaculture, to see whether it might be able to help us address some of our sustainability issues around feeding the planet more sustainably. And in getting into that research, I quickly realized that one of the things that hadn't happened in science very well to date was a fair comparison of seafood to other food. So you get a lot of studies on what are the environmental consequences of beef, or what are the environmental consequences of corn? So you have livestock or crops, and then you might get studies of aquaculture. What are the environmental consequences of aquaculture? But these pieces hadn't been stitched together to really build that comprehensive understanding of how different foods compare to each other and where are the more sustainable opportunities for feeding humanity. So this led me to work, again, with a bunch of folks based out of NCEAS, to ask and answer this question, how does seafood compare to all the other food options we have? Because if you can answer that, it might say whether or not aquaculture and wild-caught fisheries should play a larger role in our food production, or maybe shouldn't. We need to know how it compares to other food systems to be able to really answer that question. So I'm going to show you just a tiny bit of methods behind what was gone into this work, because it helps set the context of how we make these comparisons. So building on that idea of understanding the cumulative effect of how humans have affected the oceans, we wanted to understand the cumulative effect of different food production systems on the planet. And so to do that, we needed to look at all food types, but also all the different pressures that are associated with them. So not just climate emissions, not just water use, but all of the major drivers of environmental impact from food production. So we have greenhouse gas emissions. These are the gases that cause climate warming, disturbance of the land or the ocean to produce that food. You can think of row crops that wipe out the native species to grow corn or wheat. The nitrogen or phosphorus pollution that comes from fertilizers or manure or the waste from farms. And then water that's needed to grow many crops and to give water to animals. So the colors show that different food production systems use different types or create different types of pressures. You can see fisheries, because they're a wild-caught species, we aren't farming them, they have no pollution associated with them, there's no water use associated with them. So different foods have different consequences for our planet. So we did a huge effort to piece together all of this information to create a cumulative footprint of each food type, and then map that on the planet to understand where and how much each food was having an impact on our planet. And what we found, and I'm just going to summarize it in these bar plots, is basically what we call the environmental inefficiency. If the bars are bigger, it's worse. It's less efficient. You want to produce food that's efficient. That makes it more sustainable. You can get more food for less environmental consequence. If you've read the news at all, the top bars are not surprising. Goat, sheep, and cattle meat are by far the worst. You've probably heard about beef. Just the climate emissions alone are really bad, but they use a lot of water, they produce a lot of manure, and they require a lot of land to grow them. So those are the kinds of food that are having the largest environmental footprint. You can see that chicken is way down there at the bottom. It's actually doing quite well. You may disagree with the farming practices of chickens, but they are incredibly efficient at doing that, which means they have a per pound or per kilogram a very small environmental footprint. So now we can put in the seafood into this, and you can see things like benthic fisheries. These are the ones that drag those giant heavy nets across the seafloor. So they take a huge amount of fuel to pull those heavy nets through deep oceans, and they're destroying the seafloor as they drag across it. So there's a large environmental footprint from benthic fisheries. Shrimp aquaculture is also one, as we've talked about already, has a huge footprint through the destruction of mangroves. There's a lot of pollution that comes out of shrimp farms, and so they actually top the list for all of these. I actually have stopped eating shrimp because of this. It was unfortunate because I do like shrimp. But you can see that many of the fisheries, and especially the mariculture is aquaculture in the sea, many of the farmed species in the sea are doing much better than the livestock, only beat by chicken, and actually farmed salmon is even better than chicken. So this was really quite surprising to me. I didn't know what to expect, but I didn't really think this, given the narrative I had grown up in around aquaculture. We also did it for all the crops, and you can see here that things like fruits and sugarcane and cocoa and nuts and spices, etc., these are all having a much larger environmental footprint per kilogram or per pound than many of the farmed seafood species. And I think this really upended my understanding and expectations, and a lot of folks who I talked to about this, because people think of a vegetarian diet as the most environmentally friendly one, and it isn't always the case. Which means you need to think carefully about the foods you eat and make decisions, if you're interested in environmental sustainability, based on these kinds of comparisons that stack things against each other in a fair way, where you're comparing apples to oranges in a direct way. With colleagues, we also dove deeper into the farmed seafood because we didn't have all the data we needed to disaggregate these farmed species into smaller groups. But we took the chicken comparison, because it's kind of the best case livestock, and a bunch of different farmed species to get at these plots. So my colleague Jessica Meeuwig and a bunch of us did this work. These plots show you the brown bar is where chicken is. And again, if you are on the left-hand side, you're doing better. The further on the right, you're doing worse. And you can see a bunch of wild-caught fisheries, and then on the top, the farmed species. And you can see many, many of them do better than chicken. So we're seeing again and again the power or the benefit of seafood compared to chicken in terms of reducing our environmental footprint. These plots are for climate emissions. We can look at it for water use, the amount of area it takes, nitrogen and phosphorus pollution. In every case, most of the farmed species do better than chicken, which is one of the best foods out there for environmental efficiency. So this is where I'm thinking now. I'm seeing these really, for me anyway, convincing evidence that aquaculture is a really sustainable way to produce a lot of food. It's in comparison to fisheries, which this is a map of the footprint of fisheries around the world. It comes from Global Fishing Watch, which tracks through satellites where the fishing boats are. Every year we can get about 100 million metric tons of seafood from wild-caught fisheries. That same amount of seafood can be produced in an area the size of Lake Michigan, which is highlighted in red there. I don't know the comparison, maybe the size of Tasmania. Here in Australia, it's a small area that you can produce 100 million metric tons of seafood for farming. So the ability to produce a lot of food sustainably is profound. And there's a lot of ocean out there. We don't need to turn it all into farms. We can turn a tiny, tiny fraction of it into farms and produce a huge amount of seafood, food in general, that is sustainable and nutritious. So that's where I got to in the last couple of years doing this work. But I know that it can be done in ways that don't seem very sustainable. And in fact, I was in China just a few weeks for the express purpose of seeing some of this aquaculture in ways that I'm not sure are very sustainable. So this is Dongsheng Bay, just south of Xiamen in the Fujian province of China, which is across the strait from Taiwan. This is what you see from satellites. These are all farms packed into this bay, a bay about twice the size of the bay here in the Swan River. So it's super crowded. If you zoom in, this is what it looks like from an airplane just above. And this is me on a boat traveling through these farms, and it's like a city on the bay. There's houses, there's roads that are water, there's just raft after raft after raft after raft. There's tens of thousands of these packed in here in a way that is hard to believe is sustainable. Certainly there was a lot of trash and pollution in the water from these farms. There was hardly any space for anything native to be living there. It's just a completely transformed landscape. So I don't know where I sit actually on this. I think there's definitely needs to be some constraints on how aquaculture is built out. This is not, that is not a view of how I would want my coast to be anyway. I guess different people have different values for sure, and if some communities want that, then I guess that's what they can do. But it is a transformation of the ocean into something that is no longer an ocean in my mind. It is a production facility with substantial environmental consequences for that area. So that's the story on food. I want to turn now to energy. I think one of the other really big pushes into the ocean right now is for offshore wind in particular. There's other types of energy that are being explored as well. Obviously, in the last 100 years or so, the ocean has been used for oil and gas extraction. So we've had at least a century-long history of taking energy out of the ocean. In fact, the very first offshore ocean drilling was done just off the coast of Santa Barbara, where I live, and then it's since then exploded into the world economy. So we've used the ocean for energy in that way, but now we're looking at it for sustainable energy uses. And if we look at our current energy portfolio, it continues to be dominated by fossil fuels, coal, oil, natural gas. It's like 2/3, 3/4 of it. We have just up here 30,000 terawatt hours of energy being produced by renewable energies. This is mostly on land, not in the ocean. So out of the total 180,000 terawatt hours of energy we produce and use annually, what is that, about a sixth of it is coming from renewable energies, and a pretty small fraction of that to date is from offshore wind, but there is huge interest in exploring that. There are other types of offshore energy, actually, that are in the pilot phase mostly. Wave energy, there's a lot of waves out there. They're happening all the time, and there's a whole bunch of technologies that have learned to use that motion to translate it into energy. And there's expected about 30,000 terawatt hours of energy that can be produced by waves. Tidal energy, wherever there's large tides, you can either put turbines underwater and have them change directions as the tide comes in and out, just like a wind turbine, but it's underwater. Or you can build these dams that you collect the water, and then as the water drains out, like any hydroelectric dam, it drives the turbines and gets energy. And there's a pretty small, maybe 3 terawatt hours of energy potential from that. Current energy, this is the major currents that cycle through our oceans. There's quite a lot of energy from that, and they look exploring these underwater turbines that can capture that. And then ocean thermal energy conversion, OTEC, is a really interesting way of using the temperature differences, mostly in subtropical and tropical areas, where they pump deep cold water up from the below and then use the warm water on the surface to boil ammonia, which drive the turbines, and then the cold water cools the ammonia, and they can just cycle that indefinitely. So it's a really sustainable way, but it's limited in where that can happen, but it's really got a large potential for especially island nations that are in the tropics and subtropics. So these are all in pilot phase, and there's a lot of potential for them, but really the big one is offshore wind, and it has an expected potential of just a whopping 620,000 terawatt hours, about 4 or 5 times our current total energy consumption across all energy systems, fossil fuels and renewables. And that's why so many people are looking to move to the oceans for energy production. There's just so much potential. To date, it's still pretty small. It's in the gigawatt potential, not in the terawatts. So we're a long ways off from realizing that potential. And there's relatively few countries, maybe 12 or 14 countries that are really investing in this. Europe, in particular, countries around the North Sea, and China are really dominating the global landscape. And in fact, the Fujian province, where I was a few weeks ago, is one of the main places that they're putting huge installations of these giant turbines. And they are getting huge. I mean, they're getting massive. The tallest ones, the ones that are being put off the coast of the UK and China, are something like, I think, 600, 700 feet tall. And each individual blade is a football field and a half. I mean, these are just massive structures. A single rotation of one of these large wind turbines can power a home for a day. Like, it's just an incredible amount of energy production. And this is what it looks like. They have to build like temporary rigs and special ships in order to build these things. They're so massive. And then they move the rig to the next one and build another one. So it seems like just an incredible opportunity to produce truly renewable, sustainable energy to fuel our global economies. But again, like how does it stack up to the other kinds of energy production, especially the sustainable energy production? So I'll put on the table fossil fuels, but I don't think that's fair. We're going to run out of them eventually. They are the main driver of climate change. We're going to have them for a while, but we really need to phase them out. So I think offshore wind is definitely better than those. But what about onshore wind? So we have quite a lot of, right now, most of the infrastructure for wind production is on land. And it's good, but actually because there's so many more birds on land, there's much higher bird kill from on-land wind turbines than offshore wind turbines. If you know anything about what causes bird deaths, though, the main problem is house cats. It's like 1,000 times more birds are killed by house cats than by any wind turbine. So take that with a grain of salt, but if you're just comparing onshore and offshore wind is a better solution for one of the main problems for wind energy production is the harm to birds and bats. Solar is another great option, but it actually takes quite a lot of water to produce the solar panels. And as you can see in installations like this, it can take a lot of land. It converts a lot of land into stuff that's really not viable for most wildlife. And so compared to what offshore wind turbines, you could argue that it's a much smaller footprint compared to solar. Hydroelectric dams have been around for a long time. They're largely considered sustainable, but as we know, they have huge ecosystem impacts behind them. They flood areas directly behind them, but they also stop our favorite salmon from migrating up the rivers, as well as lots of other species that are evolved to move up and down rivers. They'd have to build all sorts of fish ladders, or sometimes they literally scoop them up and put them in a truck and drive them around the dam and dump them on the other side. So there's a lot of human intervention to try to mitigate the problems of that. And so we see a lot of ecosystem alteration from these dams. You could, I think, argue that what is done at the footprint of these offshore wind farms is smaller than that. And then nuclear, there's actually a renaissance of interest in nuclear energy because it produces so much and is considered pretty sustainable. But of course, you have the issue that it uses a lot of water for cooling that becomes contaminated. And it has the waste problems. What do you do with nuclear waste? And that's a really difficult challenge. So in the end, I have come to the conclusion that I think offshore wind is a really, really important and powerful part of our solution to producing sustainable energy. But I'm also concerned that if we litter the coasts with thousands and thousands of wind turbines, it's no longer a scene that I maybe want to look at, and I don't know the environmental consequence of that many turbines in an area. We just don't yet have enough evidence to say whether that is going to have a transformative impact on those marine ecosystems or not. And so I say the evidence is still, the story is not fully told yet for offshore wind. Okay, third story is minerals. This one's a bit shorter because it's still, for now anyway, in the very nascent pilot phase, but there is a lot of interest in mining the deep sea for precious minerals and valuable minerals like iron and manganese. So the areas have been mapped. These are large tracts of the ocean seafloor that have high concentrations of really pure minerals that would be easy to harvest. And I'll show you what that looks like in just a minute. But they have rich amounts of cobalt, so something like 5 times what is on land in terms of the potential for cobalt resources in the deep sea. Copper, it's a lot, but there's a lot of copper on land, but about 10% of the potential of what's on land, but it's still a lot, and copper is super valuable for all sorts of electronics and other uses. Nickel, it's about half of the world's resources are under the ocean, and manganese is massive, like 50 times what we can find on land. And these 4 minerals in particular are really useful for a lot of the new technologies around batteries and other things that we are developing to make our economies more sustainable, we need these kinds of resources. And that's why people are looking to the oceans, because there's just such rich resources there. This is the sci-fi marketing version of what this looks like from the mining companies. You have this lovely, gentle machine moving along the bottom. These nodules that looks like this, they're little balls of manganese or cobalt that are nearly 100% pure. And so that's why like they think, oh, we can just vacuum these up. They don't have to like filter through all sorts of soil and other non-wanted parts of the ground. We just can grab these. There's not a lot of evidence for what will happen, but there was a paper out just last month that was looked at this site that was done a pilot mining. This is the nodules from, what is it, 1978? And right after the machine went through, that's what that site looked like right afterwards. So you can see it clearly has an immediate impact that is huge. Maybe not surprising, you're driving basically a tank across the bottom and vacuuming stuff up and then spewing out things behind it. What was really interesting is they went back 44 years later, and there's almost no evidence of anything returning. It's not surprising that the nodules haven't returned, because those take thousands of years to build up, but there's very little evidence of anything else coming back there. So this very preliminary limited evidence suggests that these mining activities are going to have a long-term impact on the seafloor, and we really have little evidence for what that will mean for biodiversity and natural ecosystem processes down there. But of course, we also mine on land, and if you've seen what that looks like, it's not particularly great either, right? And so comparing deep sea mining to land mining is a difficult decision, right? We're going to have an environmental impact no matter what. We need these resources in order to fuel our economies and the things we want, the phones in our pocket, the cars we're driving. If we're going to do that, we need to do it somehow. Where are we going to get that from? And even though this is not a scene I want to look at, it is one that we have a lot of history now of figuring out how to manage and regulate and try to minimize the footprint and impact of mining on land, whereas we know very little about what will happen in the ocean, and it really is kind of a Wild West scene out there where companies are just going without a lot of regulation into exploring and exploiting the deep sea resources. So what does that mean looking forward? Where have I landed in my own thinking about these three stories of how we might use and are using the ocean? And I want to step back once more, just a little bit before I answer that question of where my thinking is, back to this work on mapping our impact to the oceans, because these are three uses and ways that we can potentially impact the ocean, but there's lots of other stuff going on, lots of other ways that we are already having a cumulative impact on the ocean. And so we have done a lot of work to build on that initial analysis where we mapped the human impact, and we started looking at how it's changing over time. And so you can see over this 11-year period from 2003 to 2013, you can see it getting redder and redder and redder as more and more things are moving into the ocean, and the impact we are having from fishing, from climate change, from pollution, are just spreading further and further into the ocean. And if we've just next month, we'll publish a paper that has now updated that and forecasted into the future. So this is now the current and the 2020s cumulative impact from all of these different activities. We forecast that into the future to the mid-century, and it's more than doubled. So this is like the status quo without moving offshore wind, without moving deep sea mining, without moving rapid expansion of aquaculture into the ocean. We are going to see a more than doubling of our human impact on the oceans. And the change in that is anything that's yellow, or orange or red, which is pretty much the entire ocean, is going to see an increase. There's almost no place that's going to see a decrease of our human impact. So this is the backdrop or the context on top of which these other uses are going to be laid down on top of the ocean. And so looking back at our planet ocean, what do I think we should be doing? And I guess as I thought about it, I feel like we really need to come up with what I'm calling something like a planetary deal, where if we're going to move into the ocean, something I care deeply about, which I think a lot of us care deeply about, if we're going to expand our use for reasons of serving humanity, feeding us, providing us the resources we need to do that in a way that reduces the overall footprint on our planet. So we need to reduce our terrestrial footprint if we're going to increase our ocean footprint. Or if we're going to increase our ocean footprint in some places, we need to make really aggressive efforts to protect and restore ocean areas and other places. It needs to be a fair deal, a planetary deal, where we are not just expanding into the ocean and continuing to do everything else, but we're doing this in a way that is truly trying to be sustainable. And so I do think we need to be expanding aquaculture into the ocean. I think it's a very sustainable way of producing food. I do think we should be expanding offshore wind energy to take advantage of those resources. I don't think we should be doing deep sea mining until we know a lot more about what that might look like. But in all of these cases, we need to be doing it in a way that respects the planet and our role in driving planetary processes and really our own future. If we don't take care of the planet, we don't take care of ourselves. So with that, thanks, and I'm happy to take any questions.